This is Defender Radio. I'm Michael Howie, and this is Defender Radio, the podcast for wildlife advocates and animal lovers, brought to you by the Fur Bearers. Enhancing biodiversity in urban areas is a critical step to improving our ecosystems, our resilience against the climate crisis, and ensuring nature exposure for residents. But how are we supposed to increase biodiversity on pavement? According to two researchers, it can start with stepping stones. Doctors Thami Croeser and Kirk tackled this issue and showed the brilliance of available solutions in their paper, Nature-Based Solutions for Urban Biodiversity. Spatial targeting of retrofits can multiply ecological connectivity benefits. In short, the researchers showed that converting underutilized parking spaces in urban Australia can improve ecological connectivity, the ability for various species to move across the landscape from one patch of green space to another. To share the need for such connectivity changes, how they developed and ran their study, the incredible benefits to both people and ecosystems, and what lessons we can learn, Doctors Thami Croeser and Kirk join Defender Radio. I think a clear spot to start is to just very quickly explain ecological connectivity and how that is involved with biodiversity as a whole.
Ecological connectivity is kind of this idea that we can measure how easy it is for species to move around in a landscape. Mm-hmm. We often think about it from the perspective of perhaps things like mass migration, so thinking about how things might cross an entire continent or cross really large landscapes. But it's a really relevant topic at lots of different scales. And obviously, Thami and I have been thinking about this at the scale of within cities. So how can species move around in our cities and how can we make it easier for them to do that? But it's essentially this idea that you want your habitat to be able to be either connected like perfectly, so through corridors, things like that, or you want it to be in patches that are so close together that the species that you're thinking about, whether that's a bird or a bug or, a big antelope or a deer, you want your species to be able to cross that gap in habitat. And in a city, we have habitat patches that are separated not just by kind of some interstitial space that's, maybe agricultural fields or small towns, but we have patches of habitat that are separated by really hostile landscapes sometimes. So places like very densely populated with buildings, lots of roads, lots of people, lots of cars. And so this idea of connectivity almost becomes more important because the matrix surrounding places where species are living is really potentially inhospitable. And a lot of the work that people are doing in this space in cities is trying to make that in-between space a little bit more viable for species to get from A to B.
Awesome. And in this study, you're looking at different nature-based programs or projects that are effectively converting one site into a nature-based site. And we hear a lot about this here. A great example for listeners was in Hamilton, here where I am recently. McMaster University identified a low-lying parking lot that was actually in a floodplain, realized very few students and faculty were using the parking lot, and completely tore it out and turned it back to nature. And it's glorious and making an impact ecologically. But that's one of the types of projects we can see. It's one of the ones, or that's primarily what you're looking at in this. And I'm curious, we also have green roofs. We're seeing a lot more interesting different things that way. Why was parking spaces the subject for this one? What made those sort of appealing?
Yeah, well, I mean, we have a huge retrofitting task ahead of us in cities, and it's going to really need all sorts of things. Green roofs, green walls, greening, in our front gardens and things. But most of our public space in cities is in our streets. And at the moment, the way that we've allocated that space, which is, pretty much everything between buildings, is our streets. Our streets are 70 to 80% for cars at the moment. And although when you're out driving around, you might find, oh, well, I have to look for a car parking space for a couple of minutes, and that's annoying. The reality is most car parking spaces are oversupplied in cities. And certainly what got us thinking about it in our city is that the inner city for many decades had rules which said if you built a building, you had to provide new parking for it. And certainly these parking mandates are quite common. I know that in US cities, they've historically created massive amounts of parking in cities. Yeah. What I realized when I was looking at this was we have redundancy and a little bit of duplication where you've got really big car parks in buildings sitting next to streets, which are also full of parking. And it was that redundancy that made us think, hang on, maybe there's something we can leverage here. And because we've got some good mapping skills, we were able to use mapping software to pick out where the streets were, where you've got that kind of double up happening, where you've got parking in buildings and parking on streets. And you might have an opportunity to take up to half of the parking from some of these doubled up streets. And I guess for us, it wasn't necessarily about targeting parking as much as finding those spaces in cities where we've allocated land in a way that's maybe overly generous to something that we don't need at the cost of something that we do need.
Yeah, I would just call it Walmart right on the face of it here in North America. I don't know about Australia, but I'll go to a drive past a Walmart, go past a Walmart, and they've got a parking system large enough, I think, almost for Taylor Swift's entourage, and it's never more than half used. And every time I see that, I just like, that's just make it permeable, if nothing else. Make it permeable to let water in, but it's paved. And then all of that pavement leads right into the wastewater runoff system, which goes right through the wastewater processing plant that can't handle it and right into Lake Ontario, one of the Great Lakes here. So it's often frustrating to see that. And I appreciate that you're using the parking spaces because I agree in most cities, especially smaller cities, I think we might overdo it sometimes.
And hey, like you don't even need to take the parking away to make it work. I worked on a project a couple of years back in Spain where they were just putting essentially one tree between 4 parking spaces and channeling the runoff into it. And that was enough that you actually were cleaning the water when it rained.
Yeah. And that's, well, we'll get a little into some of that too, because Toronto, I don't know if you would have seen this there. We had a significant flood incident occur. Like overwhelming the subway system, the highways. And it's a very classic example of traditional city planning and climate events happening. And it's exactly the kind of thing we'll be talking more about. But before we get into that, I think it's interesting to ask, you've talked about using mapping software to identify the sites you can use. How do you start to measure ecological connectivity in those types of things? So how do you say this site has 1 out of 5 or this has 3 bees out of 5 honeycombs? Is there a specific measurement or is it a series of modeling that you have to use?
Yeah, that's an awesome question. Thanks, Michael. So there's a lot of different ways, kind of conceptual ways to measure connectivity in a landscape. Some of them are quite complex and draw on ideas of things like current flow in electric circuits and try and model things in terms of that way, or thinking about creating kind of these very complex, they're called resistance surfaces, where you basically give each pixel in a landscape a particular value and try and then calculate the different value of different potential paths through the landscape. So one of the things I've been working on for the last couple of years is developing a method that's quite simple for measuring connectivity. I've done this specifically because I, like Thami, really like to work with local governments and with developers and the people on the ground to enable them to use this knowledge to better then make decisions in their cities. And I think it's really important that the data that they're using to do that is something that they can understand and then go away, and the methods they can use, they can replicate themselves. So for this particular measure of connectivity, we used a particular mathematical model called effective mesh size, which is all you need to know about it. And all it does is it basically says where in the landscape is the habitat, and you kind of allocate habitat within your landscape. You obviously need to spatially map that. And habitat can mean lots of things. We tend to think that it means things like vegetation, which it really does. That's a key point. But for lots of species, it might be things like, where are the bare patches of earth? Or where are the hollow trees? Or where are the water resources, the streams or the little wetlands and creeks? So it's not always about vegetation. But you identify where the habitat exists in your landscape. Then you identify what the potential barriers to movement might be. So this is about mapping typically the road network, because that's often a key barrier for movement. And that might depend again on the species that you're interested in, and we'll come back to that again. So like the species I was saying with the habitat, obviously, if you're a frog, the kind of habitat you need is different to a bird. Same goes for barriers to movement. The kind of barrier that a bird can cross might be a much wider, busier road than something that's crawling along the ground. So this is where you start to need to think a little bit about who you're measuring connectivity for. And then the last piece of the puzzle, just one more, is essentially how far that animal can move. So if the animal is going to cross a gap in habitat patches, can they fly across a gap of a kilometer, or is it going to be more like a few meters?
Yeah, and it's very interesting. So that was my next question, was about the target species. But I also appreciate you putting a hard stop and explaining the math. I am a writer by training, so anytime someone says I don't need to explain the math, I'm good with that.
But I don't need to explain the math. But
Excellent.
Just quickly, all it is an area base. So it just says, well, how much of a habitat is connected relative to how much is unconnected within your area. So it's kind of simple. But
the idea of it sounds simple. I'm sure the actual development of it and tracking and doing the math of the math is probably a little more involved than that. But again,
only tiny.
So, but talking about the species, it's a very interesting segue, because you have a bird, a bee, and I believe a leafhopper of some kind, of cricket, a mole cricket. I'm not familiar with them. Yeah. So it gives you three very different types of animals to be looking at, and insects. How did you select those three of the incredible number of species that exist in Australia?
Thami, do you want to have a go? Or
well, I can give my take.
Give your take, because I think this is interesting.
Because see, Holly's an ecologist, and she has deep, intimate knowledge of these species, whereas I'm an urban planner. So I didn't get all that kind of training. I was learning about bridges and stuff. But when it came time to choose, we wanted species that would potentially be familiar, that people knew about. So these are the kind of things that you do sometimes see in your neighborhood. So there's a degree of charisma in those species, but particularly the blue-banded bee and the New Holland honeyeater are species that we have programs or are species that we're kind of trying to bring back into cities. So we wanted them to not be just purely hypothetical organisms. We could have done some kind of beautiful stork or something that just you'll never see in the city at the moment. As it is, we wanted stuff that people kind of would know what it is and maybe have seen it, and then recognize from the audiences or from the perspective of our conservation audiences, hey, these are species that we're trying to bring back into cities right now. Like the blue-banded bee is a really quite beautiful insect, and there are programs right now in some of the inner city councils where they're trying to create new habitat for this stunning native bee. The other thing that we thought would be kind of cool would be to try and cover a range of movement modalities, from birds that can move around quite easily and efficiently to the ground cricket or the mole cricket, which is like a pretty slow beast that can probably, I don't know, Holly, how far can a mole cricket move before it gets stepped on?
We're talking about only a few hundred meters in particular for the females, which just kind of go from one patch of bare ground to another. Some of they have, as is quite common in insects, one side of the coin, the males are a bit more dispersive. So dispersive is not a word, but they're capable of moving a bit further because they're looking for those females. But typically it's something that is, really only crawling a few hundred meters at best. And certainly very vulnerable to being squashed or eaten.
Yeah, that's an interesting looking insect too. I imagine from the name that was going to be a leafhopper, and I've just done a quick Google, and they're a subsurface pest that lists them as that attack turf. So I was very wrong, which happens quite often on this podcast. It's enjoyable, but it's an interesting looking one to say the very least.
I mean, I must admit, Michael, I've never seen one. It's that you hear them, and I think maybe it's worth actually finding a little clip for your listeners. I went out into one of the neighborhoods recently and recorded one when we were promoting this paper. It's a sound that's iconic. It's for us. It's the afternoon, you know.
Oh my goodness, this is what I love so much about working in this urban space, right? Is that people haven't really ever seen one of these. If you see one, it's probably because it's like a bit confused and tries trying to find somewhere else to live. They live in burrows. They specifically dig their burrows to amplify the noise of their call. And on a hot night in Australia, in Melbourne, and here in Perth, it's this really iconic noise. And people, it's part of an integral part of the natural soundscape here, and people really resonate with it. And actually, I was very shocked when Thami and I were talking about, we need a third species. We want something that moves around on the floor. I thought he was going to say, hey, could we do like a bandicoot or a cute little mammal or a reptile? And he was like, what about mole crickets? I was like, are you serious? Yes. For a start, because we get to talk about something that not many people necessarily know about, even though they're hearing them all the time. But also, it's a really, really important part of our biodiversity. So it was great to pick a species that, to look at. I don't think they're very charismatic. They're quite alien looking.
Yeah, they're odd.
To hear, they're definitely odd. But to hear. That's a very iconic sound for us here in Australia, and one that I think if it went missing from our neighborhoods, it would be really meaningful to people. People would say, "Oh no, why can't I hear that anymore?" And I do get questions from people around like, "Oh, that noise, I was hearing it yesterday, but for some reason it's not calling today." And sometimes that's about conditions rather than in a day the beastie has disappeared from where they're living, but it's there. It's such an important presence. And I think that's why one thing I really would like to highlight about the kind of work we're doing, we're not talking about target species that are highly threatened or endangered. A lot of the work that we're doing in our cities is about looking after things that are living there, things that are not necessarily what we might term of conservation concern, but are threatened in places in our cities. They are threatened by the process of urbanization. They're threatened by all of the sorts of human activities that we're doing. And they're also really fundamental to people's experience of everyday nature. People are not going out and expecting to see on their walk to school something that is, this incredible threatened species, although we do have those. We've got incredible threatened species in our cities in Australia, and I'm sure in Canada too. We have cockatoos, we have beautiful reptiles, some incredible mammals as well. But most of the time when people are encountering everyday nature, it's those common species, and we still have to look after those too. We have a responsibility to look after those.
Very well said.
So that's another kind of point, I suppose, about species.
And it makes sense. So again, putting it in context here, the animals who are right now living in the city of Toronto are not the animals who necessarily would have lived there over 200 years ago before it was established. The landscape of the city of Toronto will never be what it was prior to colonization. So attempting to recreate that is, I would posit, unrealistic, but that doesn't mean we can't create ecologically healthy cities that have at this point arguably evolved to allow for. So I mean, Toronto raccoons, they run the city. You won't see that in a rural area because all of the predators are available in a rural area that won't do well in Toronto. So again, it's one of those, it makes sense to look at who's here now and how can we make sure they stay, as opposed to how do we try and unwind the clock maybe in some way. That being said, I'm sure this can also then apply to areas where there are highly endangered species.
Absolutely, yeah.
Maybe an addendum to that is beyond just going, who's here now and how do we look after them? Something that's beautiful about the connectivity perspective is who's nearby now and how can we bring them in so that we can have those nature experiences. Maybe there are no blue-banded bees in our part of the city now, but if they're 5 suburbs over and we can get the stepping stones going, that's the value of connectivity, or one of them, definitely, from a human
perspective. It's really true. Yeah,
absolutely. Now, I'm curious, when it was the effective mesh size methodology, I believe is the term, how does that account for the movement behaviors of the 3 different species, considering that they, as noted, intentionally move in different ways?
And it's simple because it's just a parameter around, sorry, I said the word parameter in a podcast. But it's just a value. It's all good. We very simply just have a value in the model that it says, how far in meters, how far can this species move across a gap in habitat? So it's a distance measure. You can put in multiple distance measures to get kind of a sense of variation, because one of the other, getting on my kind of various soapboxes here, but one of our other problems of working in cities is that a lot of what we're taking from the ecology and our understanding of animal behavior is actually been recorded from outside of cities. And so in many cases, we actually don't know 100%, how wide a road does a road need to be? How busy a road does a road need to be a barrier to different things? So we, to account for that, we can actually put in a range of those measures to understand something about, what does it look what does it look like if we have a low distance threshold, or what does it look like if we have a high distance threshold? But that's another kind of part of the puzzle, is we're still working with information that's not necessarily perfect, but it's better to work with that information than none at all.
Yeah, that makes a fair bit of sense to me. I'm curious, were there specific landscape features you found that were more effective for improving ecological connectivity as you went through this process? Was it a simple process as well to sort of go, well, this type of tree or shrub planted here is encouraging, or creating this type of a surface is helping? And I imagine this could go either way. Both of you would probably have interesting insights on that.
So maybe I'll explain what we modeled, and then Holly, if you'd like to talk about what you thought the kind of really decisive bits were, because what we modeled was completely the same in every single scenario, Michael. It was a parking lot where you've ripped off the asphalt, you've kind of excavated a little bit, made a rain garden that water can fall into. And then what we got was Harley's advice on native layers of planting. So understory plants, often quite important for invertebrates, mid-story plants, and then a few native tree species that provide resources primarily for birds, I guess. But the idea was this was a generic, comparable thing across different locations. So what that allowed us to do was compare the impacts of connectivity between different locations where we actually did this retrofit. So the thing that changed in this study wasn't the design, it was where we put it. And luckily, we had some great work that actually Holly had done in a previous study, finding the places that were kind of almost key gaps between major habitat areas. Do you want to tell us a little bit about what that was and how we leverage it?
Definitely. So some of this work was, as is often the case with science, you do a little piece of work and then you take that knowledge and you build on it and you ask further questions and you play around in that space. And as Thami's just described, we assumed that the design, so the species selection and everything of each of our kind of locations would have been the same. But it's important to flag that the design that we put together, which is in a related paper that's linked, like cited in this one. Yep. I'm sure Thami can flick through, or both of us can flick through a link to that. And the design of the actual parklet was created with those species, those target species in mind. So then to meet the needs of those target species to begin with. But then the location was based on, first of all, some work that I'd already done with the City of Melbourne. So the City of Melbourne engaged me a few years ago now to create a connectivity plan for the city. And as part of that work, we realized that a very large kind of proportion of the land that I didn't just realize this, many people realize this, including urban planners, so Thami, lots of people in this space, but in the City of Melbourne in particular, most of the land on which they're able to do actions for nature is within their streetscapes. So they actually came back to me and said, okay, well, we'd really like you to tell us which of our streetscapes we should be prioritizing in order to boost connectivity across the city. And so we did this piece of work where essentially I kind of went in and modeled what it would look like if essentially we kind of ripped up each street and created it into, some of the really great things we're seeing, especially in Europe at the moment, where they're closing streets off to traffic completely, pedestrianizing them and putting in green spaces and creating these linear parks. And Thami's actually done some work on this in Melbourne, so we should hit him up for a chat about that later. But so I was able to show to the City of Melbourne, here's a hierarchy of your streets. Here are the ones that are probably having the biggest impact on connectivity. And then we took that map and we said, okay, well, what if we do this kind of parklet conversion of parking spaces just in those streets that have the biggest potential to benefit connectivity? And when we did that, what we were able to show was that there was a much, much greater, I guess, per parking space benefit to biodiversity when we targeted those locations. And those locations were places typically between some of the larger parks within the city, which really kind of emphasizes the point of thinking about connectivity in these spaces. What we're doing by converting those parking spaces into little mini green spaces is making it easier for species to step like stepping stones across the city, across the landscape in between those parks, to allow them to move between them.
I've got so many questions and I'm trying to prioritize. That's why I keep pausing in between, because I'm reading 5 and going, which one? I think from an urban planning point of view, I'm now curious. How do you deal with the public's expectation? I assume it's probably similar in Australia as it is here, that I'm going to get a parking spot when I want a parking spot. Why are you ripping up my parking spot for some science experiment to really try and nail down that tone? Was there an approach necessary, or will there be approaches needed to really show people like, yeah, you might lose a parking spot or two here, but...
Right. Yeah. So that is, you've kind of touched on what the solution here is. Reallocating any public space is a very delicate thing. People are risk averse, and particularly with parking, people are very sensitive. And look, if you're a driver and you've struggled to find parking, it's annoying. And the idea that might be taken away from you is infuriating for a lot of drivers. I think the answer is very much in engagement. So it's in creating an environment in which the community actually thinks about the public space, which effectively they own. That is, your street, that is, you pay your council rates. The council manages that street, but it's our public asset. Yeah. And we can decide how it's allocated. And I think the 2 points to emphasize are, if you've got people who are deciding how they choose their streets to be shaped up, I've seen very few cases where people say, keep it black as asphalt, do not allocate a single space. I don't want trees. There are occasional radical cases, particularly when you're dealing with traders who feel like it might take away from their businesses. They don't really care if it's a street or if it's a biodiverse street. When you've got a residential street, and many of these stepping stones are in backstreet locations where you've got a quiet road, it's not a big destination, it's lined with parking. That parking's 2/3 full. If you sat down with that community and went, hey, this is a really key stepping stone, which means we could start hearing all these native birds and insects in our street again, we'd like to take up to a quarter of parking spaces, but a minimum of 1 in 10. You can make a call on that. I think in many cases you actually see communities will make a decision that is in their interest if they feel that A, they do have some control. People don't like being told what to do. Yep. But B, it's not completely radical. When we first released this stuff, some of the people that got upset were the kind of people who thought that we were talking about no parking ever, or completely banning cars from neighborhoods. And, possibly you've seen some of the conspiratorial stuff that's come out around 15-minute cities. People are capable of dreaming up really extreme situations, whereas really what we're talking about here is a few hundred spaces across a few suburbs. When you actually factor that in, it might be 1 in 20 spaces in many cases. That's just, it's not the catastrophe that people perhaps envision. And generally when you show them that they're getting something in return, next time you walk down the street with your child, they might hear a parrot and you might have something to look at together. I think we were really bad at envisioning those benefits. And a lot of the work that we've done over the years on urban biodiversity is not just our technical development and talking about the potentials, but showing people. Yeah. And we've got some really great in-house graphics. When you show people that, they actually start seeing the flip side of that trade-off. It's not just that parking might take them 30 seconds more. It's, my street could be really beautiful and peaceful. Then suddenly it's a very different conversation. And we're not good at it yet, but that's the pathway that I see.
Do you incorporate things like cues of care into the design of any of these? I'm not sure if that term is international. It's new for me. But that concept of making it part of the design at least appear very rigidly maintained, much like a monoculture lawn. And what I've understood is if you have, say, a field, you could mow 2 feet and make it appear as if it's being maintained and give people the benefit. Are things like that being incorporated?
Yeah, I think Thami was pointing at me there. Yes. So I've been working for a while with a protocol called Biodiversity Sensitive Urban Design, which is BSUD or BSUD or BUSUD. I don't know if you've heard of water sensitive urban design, but the terminology is designed to kind of sit together. But one of the things we've been working on with BSUD is trying to address some of these kind of awkward, I don't know what, trade-offs that people see around, if it's going to be biodiverse, it's got to be really messy and it's got to be wild and it's got to be somewhere where people aren't allowed. And actually, the reality is that through design, we can make it so that it doesn't feel messy, or it's messy, but in a kind of pleasantly controlled, messy way. It's absolutely a place that people can be in, and it definitely doesn't need to feel wild to still actually be biodiverse. And so, for example, very simple idea is to terrace your plantings, which is quite similar to what you've just described, which is having a mown edge to a field. And the idea is that you say, okay, well, we've got people want to walk along this street or people want to be in this park, and we need to have vegetation that's kind of in that between the ground and 1 or 2 meters high, which is often vegetation that people find or feel like they might find confronting. And that's another point. So how about we make sure that that is something that happens, and that happens in a sort of gentle way? So it's not like you're walking towards a wall of thicket and thorny bushes, but you're actually walking towards something that is, starts off with low growing flowers and then gets to something that's around knee height, and then becomes something that's more like a bush. And just kind of thinking about those simple things. And that sounds very straightforward, but actually just getting people to think about that and think about ways to be smartly providing resources for species. So that low growing ground cover, that doesn't need to be grass. Grass is actually a terrible, poor piece of green infrastructure from a biodiverse perspective. It serves a little bit of a purpose, but there's lots of things that grow low that flower. Sometimes these things are still mowable. Sometimes these things are, maybe you don't want to mow them, but they're still providing some resources to species in your landscape, but actually still allowing people to have that kind of sense of open space and greenness, which they're looking for. And then the other thing is, once you actually do start to put this more sort of wild and perhaps messy looking, what people might perceive as being messy looking things into the landscape, but then actually ask people how they feel about them, it turns out that people do actually quite like that. So there's some really great stuff, really great work over here in Australia with things. There's a project called the Woody Meadows Project, and people have been, they've gone out and they've put people, researchers and urban landscape architects and urban designers have gone out and they've put in these much more untamed feeling like vegetation, so stuff that's kind of growing and rambling around, and then actually gone to people and said, well, here's a picture of that, and here's a picture of a verge that's just grass and a tree, and here's a picture of some intermediates, and people consistently pick that more native, natural looking piece of habitat. Because when you actually have it there, and this is exactly what Thami is saying, when you have it and it's a kind of reality, people suddenly understand a little bit more about what it is that you're trying to do, and you're not, just trying to turn their backyard or streetscape into a jungle.
Yeah, and there's absolutely incredible plant selections available for a lot of what you're talking about. I took a class on naturalizing landscapes at Guelph University. I've absolutely loved it, and learning if you want a lawn that you can walk on but actually serves a function ecologically beyond monoculture, well, you can look at all kinds of clovers here. We've got Canada anemone, all kinds of different things that are gorgeous, different light soil conditions, anything you need. And like you said, there's more ecological benefit to it. And reading, I just looked this up. There's a book called Therapeutic Gardens, Designed for Healing Spaces. And it, I think I owe the library $40 because I borrowed it for too long, but it gets into a lot of the science behind psychology of viewing green spaces. And we need multiple layers and depths. We need different heights. And when we have it, our brains are just better. They're happier. The way I try and explain it to people is we can see more shades of green than any other color as human beings. And to me, it's a very telling reality. But talking about that and scaling, I think this is where we get really into the conversation. Is there more than just the tail? I need to ask Holly. I'm sorry to interrupt. I have ADHD and I'm just seeing the tail move around.
Sorry.
Oh,
this is my
nice
indoor cat Egg. So he's one of a pair. And but they have a happy life indoors where they're safe from traffic and the wildlife safe as well.
I built a catio on my girlfriend's back deck.
That's great.
Yeah, it's 5 feet tall and in an L shape, and 2 sections of 4 and 3 feet. So lots of space for them there. Yeah, they don't like it in winter, though. Apparently, domestic indoor cats don't like -30 with ice rain. Who knew?
Would have thought?
Yeah. Anyway, back where I was going. Yeah. So actually, before we get into that, Siloing, I think, is a very interesting concept that gets brought up in this. So the idea of a siloed approach of single issue green investments. City of Toronto, again, a great example. We had a massive flood that caused a lot of damage, cost a lot of money, and now there's huge conversations about stormwater management mitigation. It's not new, but it's in the news cycle again. And I'm curious, how do you try and show, I think, because the solutions you're talking about for connectivity also help with water retention and detention. How do you create a decision-making matrix maybe, or come up with a conversation of we can do more than just one thing while doing just the one thing?
I think that's really what Holly and I were working towards with this paper, because we see it so much, and it is frustrating. I think some cities have really gone quite far down that rabbit hole. Like I was reading about New York, and they've had the kind of stormwater nightmares that you've had in Toronto, but 10, 15 years ago. Now they've done all this stormwater investment with green infrastructure. They've spent, I think, $1 billion, and it's great, but it is just stormwater infrastructure. And and it might have additional co-benefits here and there, but they're not intentional.
Yeah.
So what we're hoping to contribute is kind of two pieces with this body of work. Firstly, taking this existing tool of connectivity modeling and this existing kind of analysis that existed, saying here are where the stepping stones need to be, and we're showing, okay, you can use that to figure out where investments can happen, right? But we've already, with these parking space proposals that we've done in previous papers, model benefits in terms of canopy cover creation and stormwater interception, both for flood protection, but also for cleaning the water. And we've worked with modelers of various kinds who've helped us understand what kind of benefits we can get from those. So now that we've kind of refined that technique a little bit, it doesn't really have to be about parking. What our work demonstrates is you can find a location, model a change to that location, and it might be green roofs rather than parking lots, but you can absolutely model how much greening in terms of canopy cover you can get in those locations, and you can scale it like at a city scale. You can do the same for flood mitigation. You can do the same for connecting up habitats. And that's just some of it. There's other stuff like, what are the health benefits we might see if we start encouraging physical recreation through a creation of green cycling corridors or new parks. And you can stack all of those benefits on top of each other. And then I think one of the things that's quite exciting, both for decision makers, but also people doing public engagement, is saying, all right, we have 4 or 5 different scenarios of investment. They have different benefits. What's the priority? So for example, in Toronto, where you've just been smashed by flooding, it sounds like you might end up with a single topic narrative if things aren't shifted, right? But you might come to them with this kind of analysis and say, hey, we could also have cooling benefits in summer. We could also have shade. We could also have these beautiful like amenity benefits. And we can see these 3 species of native bird in the city center if we make these investments in these ways. And ask people to assign weightings to that stuff. And you might still end up with 60% of the weight applied to the spots that work absolutely best for flooding, because that's maybe like a non-negotiable. But maybe there's 20% weighting on, creating beautiful tree canopy and another 20% on seeing birds and native insects again. And that just really doesn't need that much more thought and investment than just doing the basic green infrastructure stuff. And because of some of the work that Holly does, for example, and some of my other colleagues on biodiversity sensitive urban design, once you know that you want to do a green stormwater program, there's an emerging body of knowledge which says, well, if you want to do that, plant these species in these ways, and you will also start seeing, I don't know, water birds or these pollinators come back into your area. And so much of the cost is in the construction, the site selection, just excavating. Picking a few different species and just designing it slightly differently is actually not the bit that makes it hard. It's just finding the time to factor in that extra consideration.
And may I add? So I think one of the things that we're starting to uncover, and which is really great because Thami and I, obviously, we're an interdisciplinary team and we work as part of a broader interdisciplinary team. And we've both been able to work with people in design disciplines as well. So out there in kind of landscape architecture and in projects where they've had an urban heat modeler who's been looking at, trying to work out, what's going on with the urban heat. I've had urban wind modelers as well. And when you finally put all those people in the room together, we kind of came into a room and said, okay, here's our proposal for biodiversity. And the urban heat and urban wind people go, oh, hang on a minute, we'll take that and we'll just do a little bit of an adjustment to our models. And then we can actually start to see those really powerful synergies that come from just tweaking the design slightly to benefit biodiversity actually massively increases the benefits from the perspective of heat and wind mitigation, and water's an up there one as well. But until you put all those people in the room together to be able to have that conversation, you don't get to bring those strings. So it really is, working in this space really is about being part of a team. And that's where the really exciting kind of work happens. And then it makes it much easier to go as a team to the people who are making the decisions and say, look, here's the information and here's how all these bits actually work together. They're not in competition. And that's the really important bit. They're not actually in competition. And a lot of the time, I think up until probably actually still now, biodiversity tends to get framed and nature tends to get framed as this kind of problem that's coming in and causing, green tape and, oh no, you can't do that because you're going to, some greeny tree hugger's going to come and tell you off for damaging that bird. But actually, first of all, that's not necessarily the case at all to begin with. You're not necessarily causing this kind of cataclysmic damage in every respect. But second of all, there's heaps of ways that the biodiversity and just thinking about it actually boosts all of those more kind of human-centric benefits that we often focus on. And lastly, it often doesn't take very much. We're talking about the tiniest tweaks to a design sometimes. I've was walking through my local park here in the city I live in Fremantle in Perth, and in a play park there's a set of walls, and on two of the walls they've created tiny indentations in the top that collect rainwater, and they birds are drinking and bathing in those tiny indentations in the top of the wall. That is it's a huge, in Australia, providing water in the landscape is a huge benefit to species. And that is just such a simple change. And it's making just a massive difference. And it's tiny. It's a tiny, tiny change. So some of these things I think people think, oh, biodiversity, you've got to have a giant park and we've got to, make sure no one's going in it. And actually, no, some of this is really simple stuff. It just needs to have the conversation.
And I want to sort of wrap up on that point of it doesn't need to be citywide. It can be, and while science doesn't tell us what it should be, I'm going to say it should be. But I'm also curious, we talk about the micro version. I've been fortunate to participate in some greening projects in Hamilton where it's I'm doing the math in my head real quick, 1 meter by 2.5 meter patch of concrete next to a building that just exists as concrete next to the sidewalk, next to the street. And this lovely group, Green Venture, works with the businesses, works with the city and says, hey, it's not going to cost you anything. We're going to come in, tear that up, try and remediate the soil a bit. I mean, it's downtown Hamilton adjacent to Lake Ontario, so soil remediation is questionable at the best of time. But, all of a sudden you've got all of these native plants in there where birds can go and hang out in the middle of the area known as Steel Town, next to steel manufacturing and fabrication plants, around the corner from industrial waste. And kids now, it's like, oh, yeah, you sit and have your lunch next to a tree, next to a shrub, as opposed to on a hard bench on sidewalk. My backyard, we've got a 1.5 meter by 4 meter section that when I moved in, I allowed to naturalize on its own. And now I've selectively gone in and started pulling non-native and trying to encourage certain native. But little things like that, from what I have understood, also contribute to all of this. And I think it's so great to know that citywide we're having those conversations and your teams are showing the science and the efficacy of all of this. But it's also great to know that there's still support for those little projects that create those little steps, as you called them, to help get from one point to the next. Is that something that can be incorporated into these plans? So we're talking urban planning, big scale, green infrastructure, replacing aging infrastructure and trying to do better, but then also saying, by the way, while we do this over here, you guys can plant this tree or that tree, things like that. Is it important to incorporate those microcosms of solutions along with the large scale green infrastructure?
Look, I think that's really one of the key findings of our research in this study. Michael, the things that we modeled were a little bit bigger than the patch that you greened up in Steel Town. A little bigger. I mean, each parking space that we were looking at was probably, I think, 2.5 meters by 5 meters in size. And that was enough to have a tree, a rain garden, multiple ground story species, a couple of little shrubs. And look, for the animals that we modeled, that was enough to connect up a whole bunch of fragmented, disparate habitats. So look, one of the big takeaways is A, it works, B, it doesn't need to be massive. And I think just what you've told us has got me thinking a little bit about some of the legislative change that's happening in our city at the moment, where there are new regulations coming along, which I think we've stolen from Seattle, which say when you develop a new building, we just want you to set aside a little bit of your building footprint as greenery. That can be greenery on the front of your building. It can be greenery on the top of your building. It can be on the podium. Maybe you do a little setback and do like just a 2-meter wide garden before your front door. That is all it takes for some of our, particularly our invertebrate species, to be able to move around the neighborhood and to have those everyday nature experiences, like walking out the door on a warm summer night and hearing crickets singing instead of just hearing traffic in the distance.
Yeah.
Awesome.
And I think the nice thing is that the lessons and the specifics that we get from this kind of work, they absolutely translate to the kinds of backyard gardening, wildlife gardening projects, encouraging people to put planter boxes on their balconies if they don't have a backyard. Lots of these lessons, they're not, one of the hard things about working with nature is that it's everywhere and it doesn't obey our rules. But one of the great things about nature is that it's everywhere and it doesn't obey our rules. So whether you're talking about bottom-up action or top-down action, a lot of the themes and the requirements and then I suppose the nature rules, they can be the same across all of those kinds of actions and they're still making a difference.
To read the study from the Landscape and Urban Planning Journal, visit sciencedirect.com or click the links in this week's show notes. An outstanding article in The Conversation outlines the study and can be found in the show notes. Links to both Dr. Thami Croeser and Dr. Holly Kirk's websites are also available in the show notes. I want to thank both doctors for their time and the incredible work they're doing in Australia. Are there greening or connectivity projects taking off in your community? Let me know by reaching out on Instagram @HowieMichael, on Blue Sky @Defender Radio, or Defender Radio on Facebook. I also want to thank you for listening. Remember to follow Defender Radio and The Switch on Apple Podcasts, Spotify, or wherever you listen to get notified of new episodes dropping weekly. Until next time, I'm Michael Howie for Defender Radio and the Fur Bearers, reminding you to stay informed and stay strong.